Well, good morning, everyone, and welcome back to AIEC's Webinar Weeks, where we're not just bringing you products, but we're bringing you solutions. AIEC Webinar Weeks really aims to address today's industry challenges and opportunities along with solutions and tips to overcome them. We're really excited to have everyone here this morning. This is our 41st webinar, so that was no small feat for us. We consider that a job well done, and we've still got several lined up for you, so stay tuned for that, and visit aiec.coop/webinar weeks to check out our upcoming webinars. We've got some really good ones coming up from some AIEC staff here, Paul Dow, our videographer, as well as Chris Reynolds, our manager of Energized Graphics. So have a look at them, check them out, see if that's something you might be interested in attending. Our presentation this morning, for those of you that are looking for PE credits, we have several today that are qualified for PE credits. Reach out to Brian, he'll make sure that you get those awarded to you. Our presentation this morning will last roughly 40-45 minutes. We'll leave 10 to 15 minutes towards the end for Q&A. As always, please remain muted for the duration of the meeting. We do ask that you submit your questions through the chat function. Use the drop-down box and select AIEC. That'll direct those questions to Brian and myself, and we will moderate those questions to the presenter on your behalf. Every now and again, if a good conversation comes up, we may open the floor, and if that happens, I'll definitely bring that to your attention. With that, Brian, who do we have joining us this morning?
Our presenter today is Tim Stalins. He is the product manager of anchoring at Hubbell Power Systems, with responsibility for marketing, new product development, and product training for the Chance brand of anchors and helical piles sold to the communication and electric utility markets. Tim has been with Hubbell Power Systems for 35 years, and with that, I'll hand it over to you, Tim.
All right. Thank you very much. Just making sure my slide changing. You guys can see it, Brian. All right. Very good. So my name's Tim Stalins. I've worked for Hubbell Chance 35 years, basically out of the factory that's in Centralia, Missouri. Been making anchors there for 100 years, and I work there right now. I'm working out of my home. The factory's been up and running throughout the pandemic, but they asked us to stay home at least for, I don't know, maybe another month or something like that. So all's good. So the factory, I don't know if anybody's been through the factory. We before the pandemic used to give lots of tours. People would come in and visit, and we'd walk them through the factory, and so we make a lot of the anchors there. You can see we do some of the forging. Example, forge an eye on the end of an anchor rod. We forge sockets on the end of square bar anchors. We do a lot of robotic welding. I don't know, maybe 75–80% of the welds are done with robots. We also have a galvanizing facility, which is puts zinc coating on, and so world largest manufacturer of anchors. So we sell anchors, traditionally into the kind of the utility, the communication market, but also sell them into what we call the civil market, which is putting anchors and pipe piles under buildings. You may have seen some of our ads for like home underpinning type stuff on TV, or heard them on the radio or something like that. So I'm going to walk through a few things today. One is how to pick the correct anchor. There's a number of different anchors on the RUS listing, and I'll kind of walk through that. You probably have some on your standards that you traditionally use, but maybe there's some situations where you got an extra heavy load. You got maybe some soft soil, hard soil, maybe some rock or something like that. And we'll walk through some of the different scenarios. Talk about some of the anchoring tips. How deep does an anchor need to be? Does it need to line up with the guy? How close does it need to line up? Things of that nature. And we always talk about safety. The trucks that install the anchors, your digger derricks are getting bigger and bigger every year. More and more force, more and more things to consider when installing the anchor. So I'll walk through a couple topics on that, and then of course questions at any point. All right, so anchor failure. So very seldom do we ever see an anchor that's sitting on top of the ground, right? If an anchor fails, traditionally, the anchor just kind of pulls out of the ground, maybe 6 inches, 8 inches. You might notice that a pole is leaning, and it can cause a number of different issues, right? You got your hardware that's up there trying to hold the conductor in place, and it's now no longer lined up. You got your conductor sagged more. I mean, I've had people tell me that they've had conductors slapping together and causing some issues, and the problem was actually the anchor that pulled, and the pole was leaning and causing some issues. So we'll talk about picking the right anchor and making sure it's installed correctly. All right, so the RUS standards. So there are a number of different standards out there. This is the last one I've seen. I don't think it's been changed since I last checked late last year. There are some holding capacities that are shown in the charts. I wanted to point out that the capacities there are the not the maximum that the anchor is going to hold, but what the kind of the design loads are. You know, what you expect to have that anchor at when the whole system's in use and in place. So there's a couple different anchors there. There's an expanding anchor, the screw anchor. I'll walk through some of the different families of anchors, but I wanted to point out the note at the bottom, because this is what gets some people in trouble, is that it assumes that these capacities are on a class 5 soil. And if you look at the standards, the RUS standards, there is a listing. I think I have one here. Okay, so here's a soil class listing that shows soil classes from class 0, which is hard rock. And as the number gets bigger, the soils actually get softer. And the standards are listed as a 5. And a 5, I don't have the word listing here, you know, to describe the different types of soil, but it's basically, I don't want to call it cornfield type situation, no gravel, things of that nature, pretty soft soils. And one of the things that the standards talk about is when you're in softer soils, like a class 6, class 7, around central Missouri where we're located, we get quite a bit of class 6. We got our own truck, and we do some testing and put anchors in. And so depending on where we're at, class 6 can surprise people. It can be a lot softer than they expect. And so the standards ask you to derate the value by 25%. If it's class 7, derate it by as much as 50%. And it kind of mentions class 8, which is really swampy material. And the best recommendation, that kind of soil, is to install a type of anchor like a square shaft anchor that you can extend deeper into the soil and get into better soils. Let me go back one. So you see the values here. These are the kind of the standard ratings for the different types of anchors. You can see a number like 6,000, 8,000, 10, 12. And so they're asking you to derate them when you get into softer soil. So you're talking about really not a whole lot of capacity there. So there's the derating values and then the soil classes. So let me walk through some of the families here. So the first family of anchors is the expanding anchor. It's been around since the 1940s. It's been a very good anchor. It works well. You can see the holding capacity that we have, that we show for the different size anchors. And the anchors are sized based on the size of the hole that they're supposed to be installed in. And most common is the 8-inch. It is by far the highest volume, and it's supposed to be installed with an 8-inch anchor auger, as we call it. You know, it's a fairly short auger. The crews I've been with would normally have their pole auger, and to install this anchor correctly, they'd have a second auger that's about the size of the anchor, either 8-inch or 10-inch. We have a 10-inch on our truck. So the way they're installed is you would auger the hole in line with the guy. You would install the anchor, and you can kind of see that there is a cone, and underneath, it's a little bit harder to see, there's a base. And so after the anchor rod is installed through through the cone and the base. You put the nut on the back side. You clip the wires that hold the base and the top together, and then the anchor is installed. And then there's a tamping bar, a busting bar as we call it, that used to bust that cone out into the sides of the hole. And that's where the real strength of the anchor comes from, is having that hole about the same size as the anchor, having the proper size hole. And after the anchor is busted open, you backfill, tam. But where people have come in and had issues is when they do use the pole auger. You know, you use a 16-inch auger. You basically have loosened up all the soil, and you don't have a lot of capacity for the anchor. So some of the different utilities have come to us after storms, and they've had issues with some of the bust anchor pulling, and they investigated, and some of the anchors either were busted and the hole looked too big, or the anchor never got busted to begin with. It just got dropped in the hole and backfilled. So very good anchor if it's installed properly, but it has to be installed properly to get the values that you expect. You can't tell once it's backfilled and tamped. So. So the next family of anchors I was going to talk about are the screw anchors. I'm sure most people are familiar, but I'm never quite sure who's going to be participating in a seminar. So we're talking about the type of anchors that are installed with the truck. You can see the image on the left shows a digger derrick, digging a pole hole. To install the power installed screw anchor family, you would drop the auger, you pull the pin, what we describe as the Kelly bar, the drive shaft from the torque indicator. And you can see the image on the right where you have the torque motor kind of up toward the top. You see a brown hex-shaped bar, and we call that a Kelly bar. Then it attaches to tooling, and the square bar that's attached to the anchor is actually hollow. So the anchor rod fits up inside there. And so that square bar, we call it a drive wrench. Some people call that the Kelly bar. But in either case, the whole idea is to get the torque from the torque motor transmitted all the way down to the anchor, and not try to screw through put the torque through the anchor rod itself, because the anchor rod will twist up. So look at some of the different types of anchors on the market. There's two basic families, two different designs have been developed over the years. The industry started out with the bar hub style that's shown at the bottom, and that hollow square tube fits down over the square bar. And that design still works today. We still a number of them, but in some cases where you get into harder, rockier soils, the truck is big enough and strong enough that it will actually break the square bar in the anchor. And that's, when you install an anchor and the bar breaks, you know it, the crews know it, it pops. But it's kind of one of those things where if you do have harder soils, some of the utilities are moving to the socket style. And the idea on the socket style is that the square wrench fits inside the socket. And so there's a lot more bearing capacity for that from the socket, and you get on the square bar. So I want to call it the torque capacity, the amount of torque that the truck can put on the anchor before it breaks is a lot higher with the socket style. They're more expensive, but it's kind of one of those things. If the bar hub type works for you, economically it's the best. But if you're having trouble with crews hitting rocks, or even sometimes in the middle of summer when the ground's really dry, just to get through the first couple feet, it can be some pretty tough digging. And so one of the things we're seeing is that people using the socket hub more and more. Both of them are on the RUS listed material. The longest time, just the bar hub was on the listed material, and then in the last probably 3 or 4 years, we've added the socket hub. They've allowed us to add the socket hub as well. You can see the table that's in the center. It shows the different helix diameters. So the smallest really in the industry is like an 8-inch style. Then they get bigger. These are all kind of single helix is what I'm showing here on the chart, to go from 8, 10, 12, and then 14. Put an 8-inch into the like I say, the cornfields of Missouri, cornfields in Illinois. You may have some issues getting kind of the capacity you need. The two sizes that are listed for the on the RUS listing are the 12 and the 14. Like, I think they're 6, 8, 10, and 12 is what the ratings are, and the 6 and 8 are the 12-inch, and then the 10 and 12 are the 14-inch sizes. So, but when you get into the 12 and 14, if you get into some of the harder soils, some gravels and stuff like that, you might have some trouble getting them installed. There are utilities that will even though the listing has 12 and 14, they will look at using the 8 and 10 in situations where they got harder soils, and you can get the capacity you need as long as you got the harder soils. The key to these are the torque, and you can imagine, as we talked originally about the bust anchor. You're digging up the soil, you're disturbing the soil. The key with these screw anchors are that they do not disturb the soil. You can slice them down through the top layer and get down into firm soil, and the torque that's required to install them does provide a way to measure capacity. And there are indicators or tools that are available to measure torque. Honestly, there's not a lot of people that are measuring torque for like just a distribution anchor, a single helix. But when you get into some of the bigger anchors that I'll talk about here in a little bit, the multi-helix anchors, it is real common for people to use a torque indicator. So I'll talk about those as well. So some of the things we're seeing, I've talked about the different families of the screw anchors, the bar to the socket. People are converting more and more over the years to the socket style. There is a difference in price, but when you're talking maybe $5 an anchor or something like that, you think about a crew that goes out and tries to install a bar anchor and it breaks, so they have some issues with it, or they got to come back, get another anchor, or they have to install a bust anchor, then they might find it more economical to use the higher torque capacity, the stronger anchor, the socket style. Anchor rods, the other thing we're seeing is more and more people are going to larger diameter anchor rods. There is a 5/8 inch that's on the RUS listing, and 3/4. We sell more 3/4 and 1 inch, a lot more than we do on the 5/8. And so people like the extra strength you might get out of the 3/4, 1 inch, but also you have a little bit more steel there for corrosion issues. You maybe have seen over time where an anchor rod will start to corrode, it starts to pencil down. And the bigger the rod, the longer it'll last. A 5/8 inch diameter is really not that large. You get a lot more steel with the 3/4 or the 1 inch. We do sell a rod that has a protective coating on it. It is galvanized. It has a zinc coating. Then we dip it in black asphalt paint and put a tube over it. And for different locations, different areas that have a lot of corrosion, they are more often using these rods to help trying to give more life to the rods, protect the poles, and help kind of give you another layer of protection to keep that pole standing. So we see fewer of the 1 inch or the eyes, but more and more people are using 2 and triple eyes. All right, so the next family I just want to talk about was the multi-helix. And over the years, more and more people are using these. They kind of originally were used primarily for transmission, and they are today, but more and more they're getting used for distribution, like a big dead end, or you have some kind of pole you have to set where you have a big dead end, or you're going to have a long span. You got some very soft soil, And I'll describe how these are installed, how they're different than the other screw anchors we're talking about. So with this family of anchors, there is no hollow tube that's used to install them. So the other screw anchors, the tube actually goes in the ground. Once you install that screw anchor, you have to pull the wrench out of the ground. Well, with this family of anchors, the torque is applied through the shaft, and the tooling never goes into the ground. There is a short drive tool that's 10-inch long that goes from your traditional tooling to hook right to the top of these anchors. And the crews would install the helical section first, call that the lead section. They install that in the ground, and then there's you see the image of the extension, which is the center there, and it attaches to the top of the helical section that's in the ground, and then you hook the tooling back to the top of the extension. So you can install the lead section, the helical section in, and you can actually add multiple extensions, and that's really common for crews to have to use maybe 2 or 3, or if you're in a really bad spot. I've been places where you have to go down 50 feet to get a good anchor, so that you have to add extensions, and it is one of the kind of the few methods of anchoring where you can get more capacity from an anchor in a certain place without having to add additional anchors or whatever. If you had a pole sitting in a place that you got a big span going across the highway, you have something where you need a lot of capacity or soft soils, these anchors are used more and more often. You can see the table there. There's the first column shows the dimensions across the flats on the square bar. The most common is 1.5 inch. That's the family of anchors that are on the RUS listing. But what happens in some situations, you get kind of a hard layer. You go through maybe a top layer that's soft, and you just hit a soft layer, and sometimes these can torque up, and you might have trouble getting them in the ground. And so people that use them quite a bit or have a big project use the 1.75 inch. We're seeing some of the big transmission jobs are using the 2-inch square bar. And what that allows them to do is not only get more capacity out of the anchor, but if you do hit some harder soils, you're more likely to be able to penetrate through it and get the anchor installed. Just the last piece there is the guy adapter, we call it, or the head. They come with different eye configurations. Also this version has a pulling eye. You can see the little almost teacup handle on the side, and that's used to hook up your guy, hook your hoist through it, and set your grip on the anchor eye. So some of the trends, we talked about kind of conversion from the single helix to the multi-helix when you have higher capacity required, softer soils. Some people have to set 2 standard anchors, either 2 bust anchors or 2 guy single helix screw anchors. And so they might want to say, hey, we just want to set 1 anchor, and we're going to use the higher capacity multi-helix. Then I talked about the larger shafts and being able to penetrate harder soils. All right, so here's something that's kind of unique about this family of anchors. Is I talked about the torque is applied to the top of the bar. Eventually the helixes, the blades will get into firmer soil, and you can start to twist the square bar. The image here in the photo is actually too much twist. And the rule of thumb that we use for this family of anchors is that the maximum capacity that we allow on the anchor is about the same as 1.5 twists across 5 feet of the anchor. And it is kind of odd to think that a manufacturer would say it's okay to twist, so this anchor and leave some permanent twist in it. But it doesn't need to have it. I mean, that's kind of the maximum. If you know the capacity you need, it might be something less than that. But there is some twist allowed to get to the torque capacity that we say is the maximum. And there's some crews and supervisors and stuff to say, hey, I want to see a little bit of twist in that anchor so I know it's into something solid. Here's a chart that it doesn't happen very often, but I use it when I talk to crews that use these multi-helix anchors a lot. And I describe it as, think about going down the highway and you see a cut along the side of the highway and you can see layers of soil. You know, you can almost picture some of it being softer, you might have a harder layer, something with some gravel in it. And so that different layering of soil, you know, is common everywhere you go. And this is a graph that's was kind of very unique. It's down in Louisiana, but it shows the depth that an anchor was installed across the bottom. You can see like 10, 20, 30 feet. Then you can see the installation torque. We had a torque monitor on it, and you can see as the anchor got deeper, the torque built, but then it punched through a layer and then got soft. And so it went down to like 30 feet, it got hard again, then got soft, and eventually got harder. So I use this for crews to remind them that there are layers. You can get down to a layer and get it into solid soil. We recommend that you get it a couple feet into a good solid layer, but don't be surprised if you break through and then you go down deeper and it gets softer. It can do that, and it's caused problems. It's caused anchors to creep if you don't leave the helixes in some of the solid soil. The other thing that we have concerns about is if you're going through some soft soil and then you get a hard layer and the anchor torques without advancing. I almost think about it as the anchor sitting on top of a rock. Right? You know, it installed 10 feet in the ground, all of a sudden it hit a hard layer, and the torque built, but it didn't continue to advance. And so those helixes really are sitting in some of the softer soil. So our recommendation most people is that you kind of look at the torque over the last couple of feet of installation to make sure you have a good solid anchor. All right, some anchoring tips, some things to think about when you're installing the anchor, and installing an anchor can be difficult, right? Because you don't see it, what's down there, you don't know what's down there as compared to framing up a pole or something. And one of the things that we ask you to look for is water tables. So if you're into an area where you do have a water table, it can reduce the capacity up to 50%. That's quite a bit, and it kind of depends on the type of soil, you know, whether it's sandy or silty or whatever. But just be aware that that changing water tables can have an impact. If you install it while there's water there, it will have less torque, and you can kind of pick up that it's a softer soil. But if it's some unusual situation where the water table changes a lot and maybe moves, you know, a couple feet or something like that, it could have an impact. Maybe down in a creek bottom, river bottom or something. The other thing is the depth. We want to make sure that, let's say, a single helix type anchor that's installed or a bust anchor is about 5 feet in depth vertically. And the best way I describe it, the way you can think of it is, imagine screwing a single helix anchor into the ground. You install it a foot or two, and you pull up on the boom, and you know the whole soil above it kind of comes up and kind of busts through the surface, and you don't have much capacity. And the capacity of the anchor when it's installed, this 5 foot, it's different. It doesn't pull the soil up and doesn't disturb the surface. It's basically shearing the soil like you almost would break through steel or something different than interacting with the ground level. And so the recommendation 5 feet. You get shorter. We don't really have like a D rating factor, but it does have an impact. And you can imagine too, you get it softer, not softer, but shallower. You get a lot of rain, you get during the spring or something like that, and you get water down there, and there it can impact it as well. So make sure you get the depth on the anchors to get the capacity that you need. Spacing, I'm sure you have your own spacing requirements. You got people out staking it, but there's always issues. You got limited space, you got limited right of way. For two anchors to act independently of one another, they need to be about 5 feet apart. That's kind of the rule of thumb. It's not always able to be done, right? You bring them together, just realize that as you bring them together, you have some less capacity in them. Not necessarily an issue if you're 4 feet, but if you have to set them side by side, you can see this image up here, 4 anchors, sitting right side by side. And, if that pole is going to go, it might be because all those anchors are hooked right, next to one another, or installed right next to one another. So installing them, they should be installed in line with the guy. Our recommendation is plus or minus 5 degrees, which is, it's very tough to do. Not always done that way, but the better you can line them up with the guy, the better off the anchor is. I think I have some images. Yeah. So, worst case, if somebody were to install one straight up and down, you can kind of picture that 3/4 inch rod or whatever eventually, bending and pulling through the soil, and your pole is leaning, and, you can have all kinds of issues that you don't want. So the better you can line them up, better the situation. Matter of fact, I think I got an image here of an anchor rod that was sent in that broke. And so this is a 1-inch rod. So even the biggest rods, when they bend, they can break. And you never know what they're going to bend around. It could be bent around a rock, or it could be, could be a gentle bend. It could be a bend that happens right in like one area. So just be aware that misalignment can be an issue. The other thing I remind crews, and your engineers and stakers understand this very well, but I just kind of remind people that as you move the anchor closer to the pole, you need more capacity out of the anchor. And it's easy, obviously, sitting in the office and talking about that, and you're out in the field and you don't have the room. You got to move that anchor closer to the pole, but just be aware that you need more anchor as you get closer. And you can read the numbers here, but cutting it in half, you almost need twice the anchor. You cut the lead in half. So be aware of that, especially if you get the situation where you got to move the anchor closer to the pole, and maybe you don't get the depth you want. You're setting a couple of anchors. All those things can kind of stack up and be an issue. Just another photo of twisted anchors. It happens. These here was the photo was sent in. It shared them with our engineers. Basically, had to say, hey, we can't recommend that you use these anchors. They're just too much twist on them, and almost like like a paper clip. You bend it once, it's okay. You bend it a couple times, and eventually it could snap. And what we see sometimes is that crews want, they want to do a good job. They want to have all anchors. Let's say they're setting the 3 anchors like you got in this photo, and you want them all to kind of line up and be about the same height. And you can kind of see the anchor that's closer to us on the photo has more twist in it than the one further away. And assume it, even in the shard area, there's harder soils, and they were trying to get them all kind of the same height. And I'm sure the RUS has some kind of requirement as far as height above the ground, but like for a manufacturer, we don't necessarily care how high the anchor is out of the ground. We just don't want you to overwork it or over torque it and overstress it. The tooling I talked about, the one on the left there is for the kind of the power and salt screw anchor. The one on the right shows you how the multi-helix is installed. We do have the torque indicator on our truck because we're measuring torque. We're pulling anchor, testing the capacity and things of that nature. Some of the names, terms that we use in the industry for the anchor tooling. The Kelly bar adapter is a casting that's the image on the right there, and it hooks to the drive shaft on the torque motor. We call that drive shaft a Kelly bar. The next anchor tool that's in the image is a cutaway section. So it doesn't normally look like it, because normally it's a solid full casting, and it's called a locking dog. And the pins that come in from the side are called dogs, and they hold not only the tube in place, or the drive wrench, but they also reach inside and hold the anchor in place. The top of the anchor rod has a hex forged into it, and the dogs fit underneath that hex and hold the whole anchor in place as it's being installed. We do have 2 families of anchor tools, kind of the standard one. It's rated at 10,000, but as trucks continue to get bigger, some of the 2-speed diggers, some of the bigger torque motors, go up to 12, 15,000 foot-pounds, and some crews want to take advantage of that torque and then rockier soils, and so we have higher capacity tooling that allows you to install those anchors in. Safety, the toolings can get worn out. I know it's not uncommon for you to wear out a truck, or a truck, least time to get up, and you take the anchor tools off one truck, you put it on the next one, and before you know it, they have 10 years on them or something like that. So we do have an anchor encyclopedia that has photos of different things to look for. The bolt that's in this photo actually has started to shear. So the bolts hold the different Kelly bar assembly to locking dog adapter, and there's a lot of torque applied to them and bending, and so we ask you, for one thing, check these bolts, make sure they're tight. The other thing that we've seen is that the Kelly bar adapter that attaches to the torque motor drive shaft, we do supply a special pin with all our tools. If the crews don't like them, if they want to use a bolt and a nut, we have had situations where people have gotten hurt because the bolt has flown out, whether they put the nut on it or maybe the nut vibrates off. The safest scenario is using this bent arm and this coil lock. And if you've been around an anchor that's installed in harder soils, you get a lot of chatter, you get a lot of acceleration, a lot of the anchor goes, stops and starts, and stops and starts, and the crews are doing what they can to get the anchor in, and if they hit something solid, the pin can, if they're using a bolt, can come flying out. One of the worst situations is where you use a click pin, which you might use on a tractor or lawn tractor or something where you're just holding the pin in place, but those click pins open up and come flying out. So, checking on the time, just about ready to wrap up here. We do have a checklist if you have concerns about your tooling, what to look for, how often you should be checking the tooling. We do have a checklist that's on our website. We can get you copies of it. Gives you some recommendation on what to look for too. So, just last couple slides, I wanted to point out that we do make other things besides guy anchors. We make some of the pipe screw-in foundations that are used under transmission towers, substations. You can see the image in the lower left is a solar field where the helical piles are put in. Matter of fact, that one had the requirement of looking at the whole cost of the project, even after the life of it, how much it was going to cost to take the concrete out, and was the concrete going to go into landfill or not. And these screw anchors were installed at the end of the project. They plan on unscrewing them and throwing them into a recycle bin. So all that can come into play. Here's a project that we worked on in Northeast Missouri. It was in a T&D magazine article. They use helical piles to help make their foundation stronger on substation. They were upgrading the substation, needed more capacity out of some of the structures. And you can kind of see where the screw anchors were installed. They were rebarred in and the bigger foundation poured. So that's one way. That's almost like a retrofit. We also do for new construction and substations as well. You can see some of the different ways. Sometimes the tower is connected right to a pipe. On the right there's some substations that are hooked to bigger pipes and directly into them. The lower left is really common, is where you're using the helical piles as kind of the deep foundation, the footings, if you will, and then tied into a cap at the top. And then on the right there is the transmission tower, where they use smaller helical piles, and we make a grillage, like a base type system that ties the helical piles into the tower. Kind of, again, wrapping things up, we do have an anchor encyclopedia. It's online. We can get you copies if you need. Just kind of let us know, and we'll get you what you, if you want copies, we can get those sent out to you. If you ever have a situation where you got a project and you got some soils, if you have any soil information, maybe from sometimes they'll get soil boring at a substation nearby or something like that. But if you have any soil information, you have loads from what you need for the guy's structures, you can send them in to us, and we can give you a free anchor recommendation on what you should use. In a lot of cases, it's a situation where the people are, have an ongoing project and they find some soils that they weren't expecting, and they need some recommendations, and so we do that as well. Do some training seminars. We used to be in person. Last year we did them webinar, but we'll be back to doing them in person, whether it's this year or next year. And if you have an interest in coming and seeing the factory, seeing some anchors put in, we put the anchors out, in the field. We do some pull testing, kind of walk through all that. So if you have interest, let us know. All right, so I think that's my last slide.
All right, thanks, Tim. We do have a few questions, and if just a reminder to any of our attendees, if you have any questions, just feel free to put those in the chat function and direct them to AIEC, and we'll moderate those to Tim. But the first question I have, how do you determine the holding capacity of a screw anchor or expanding anchor?
Yeah. So kind of as we talked about as a review, for the most part, people are using kind of the type of soil, whether it's like gravel in it, whether it's soft soil, going to the charts, either the RUS or our charts, and estimating the capacity. It's not a complete science if you don't measure the torque. Measuring the torque will help reduce the risk on what determining that capacity. But one way or the other, whether you're making an estimate from the soil type or whether you're measuring the torque, that's how you determine the capacity.
Thanks, Tim. The next question, how deep does an anchor need to be to get the expected holding capacity?
Yeah, again, kind of a reminder, 5 feet is the recommendation for kind of a single helix. As you get shallower, you got to be concerned about the anchor not having capacity, about water tables, things of that nature. So rule of thumb, think 5 feet is the recommendation.
Next question, RUS uses soil class to estimate holding capacity of an anchor. What are the soil classes?
Yeah, so you'll see them listed on the RUS listing. We have them online. I had a slide for it. Just a reminder, they start at 0, which is solid rock. They go up to, the soil classes go up to 8, which is almost like muck, almost something you couldn't walk on. But the RUS uses as a general rule of thumb soil class 5, and 5 is good solid clays, not any gravel, things like that nature. So if you kind of you're digging a pole hole and you look down and you're getting some gravel, it's one of the things you're you're at least as good as a 5, if not stronger than 5. So.
All right, next question. How closely does a guy anchor need to align with the guy wire?
So the rule of thumb we have is the plus or minus 5 degrees. Very to say difficult. No one ever measures it. But if you stand back and you're looking at the guy and the anchor and you see that they're not really lined up very well, just recognize that it's one of the concerns when installing an anchor, that the more out of alignment, the more bending, the more the pole can lean. So just something else to look for.
All right, the last question, what are the safety concerns when installing an anchor?
Yes, so think about the torque put out by that truck. I mean, it's the torque rating is like 10,000 foot-pounds, 12,000 foot-pounds. When you talk about, I kind of look at, saw a commercial for an F-150 and it puts out 300 foot-pounds of torque, right? You know, they advertise how much torque that is, and that torque motor that you don't think too much about on the digger derrick puts out not 10 times, not 3,000, it puts out like 12,000 foot-pounds. So really be careful, really be observant that when you're installing an anchor, how much force is there, and make sure that the tooling's in good shape, that the bolts have been checked, you got the right bolts, and things of that nature. So things to look out for.
Well, Tim, I think that's all the questions we have. We want to thank you for your time. Do you have a contact slide that you can put up for us, or maybe just put a shout out how people can get in touch with you?
Yeah, so I don't have a contact slide up there. Greg Deinhardt is our territory manager, and he's on the call. He'd be the one to really get in touch with for any of the Hubbell Power Systems product information. So
excellent. And for our attendees today, like usual, if you need to or have interest in reaching out to Hubbell or Tim or Greg, feel free to reach out to myself or Brian or Ashley, and we can definitely get you in touch with them. So again, thank you very much for your time today. Very informative. Very much looking forward to the days when we can potentially come out and visit the plant and see this stuff in person. So maybe hopefully even see you at our fall conference. So thank you very much for your time today.
Yeah, thanks everybody. Have a good day.
Thanks, Tim.